while we're here, I figured I mention. So this morning, the flight readiness review at NASA wrapped up.
And there go.
My mom thought it'd be cool, so she let me come in and listen to the poll.
Oh, that's amazing.
If any of y'all listening don't know, before every human launch, they do a big review of all the parts of the spacecraft, and then every agency and program involved has to say, we are go and approve the launch.
Mm-hmm.
But for big historic launches, like the one on May 27th, it's like the Oscars, because every single agency has a short little speech thanking this person, that person. It's an honor to work here.
Jesus Christ. Just launch the damn rocket. Come on.
But at the beginning, Elon Musk got on the call to say a few words. And what's funny is he got disconnected because his Wi-Fi crapped out.
Oh my God.
Which makes me happy because it shows that no
Remember,
man
you are
or
but
woman,
a man.
nobody is above bandwidth. And then he gave what I believe is the worst remarks I've ever heard. It was 3.5 minutes of stutters, long silences, and repeating himself.
I love Elon,
course.
but listening to him speak in public is so painful.
Hey,
he's a great guy.
Slack.
It was
What? Oh, never mind. Yeah, I mean, he's not the best public speaker, but
or private speaker,
I guess.
But yeah,
he does quite amazing things.
Anyways,
we'll give it a few more minutes just to make sure everyone gets in.
All right. So in the meantime, here come the jokes, baby.
Oh no! Oh God!
So I got a new dog.
We're trying to retain new members, not drive them.
Oh yeah, you're right.
So I got a new dog, guys. It's super cute. The only problem is it always chases people on bicycles. Yeah, it got so bad we had to take the bicycle away from him.
I actually thought you got a new dog for a second. Wow, I am gullible.
I
love
that.
Mike has told me that joke 3 times.
Yeah. Oh God.
I haven't heard that
That's a
one in
good
a while.
That's my favorite joke, really.
That's what y'all gonna do in Eclipse is at 6:30 in the morning in the O deck before going to hot fire. You have people who all look like they just went through a car wash telling terrible jokes. Incredible experience.
Or 7 a.m. at a rocket launch. Stop pushing the propulsion.
We're just better. We can't help it.
It's the only time I've enjoyed being up that early.
Yeah, it's a lot of fun. And those road trips out to the launch site, A1. And we have a tradition where before any launch or test that we do, we always go out and get kolaches. And it's the only time that I ever have them. And so it's just
What are kolaches, Mike?
For those of you who are unaware of kolaches, they are a pastry
Food of the gods.
Unique to Texas, I believe. They're originally, I think, Czech. I think they came from Czech immigrants, but they're dough balls filled with stuff.
Wait, are kolaches not widespread?
No,
I didn't know what they were until I came here.
Yeah, until I came down to Texas, I had no clue what a kolache was.
I had no idea people did it until Eclipse.
See, it's like a total dichotomy.
And now every time he hears that,
You just don't go to sleep the night before.
so he gets all aggressive. It's because he fucked up my neck. I fucked that nigga.
Oh,
Yeah, he fucking.
Oh, we got a hot mic.
yo, my guy, give a hot mic. No. Yo, Nick, can you help out our friend?
That works.
I always feel like a dick when I do that.
Sometimes it is.
I just don't think he knew his mic was on. So
Yeah.
It's way too easy to power trip when you're running a Zoom call because if someone raises their hand, you can click lower hand.
Oh no.
My favorite is the mute all button where you can just shut everyone up.
Absolute power.
Oh man.
Nick, was there any? Oh, sorry. Go ahead.
Change people's names. I love that one.
All right. Well, while we're waiting, why don't we go down? Y'all, introduce yourselves.
Sure.
Yeah.
All right. We'll get into introductions more during the panel. I have some. Well, no, I'm gonna introduce myself now as well. But just so everyone's aware, I'll go through some. We're gonna go through a short presentation, but I'm Jeff. I'm the president of Rice Eclipse. I'm a senior right now. I'm a mechanical engineering major. here at Rice.
Hey guys, I'm Mike. I'm a rising sophomore, and I am the design lead for Rice Eclipse.
I'm Kimberly, and I'm the aerodynamics and structures lead.
I'm Caroline. I'm the former chemicals lead.
I'm Anissa. I'm a rising sophomore in electrical engineering, and I'm the testing lead.
Hi, I'm Nick. I'm the moderator. I'm a rising sophomore, and I'm the Luna lead, which you'll hear about later in the presentation. But yeah. So how's everybody doing?
Yes. Yes.
Hey, buddy.
We have one. Yeah.
Oh, we got a what's up, Jeff.
We got a what's up? Fantastic.
What's up, Jeff? Anyway.
Hello, what's up,
I
Jeff?
think we might as well go ahead and get started with the presentation. So Jeff, do you want to take it away?
Yeah, sure. Nick, was there anyone else that was waiting to join, or I think now's a good time to start unless there's someone else who's trying to get in right now.
Nothing I know of right now. Just give me 1 sec. I'm trying to figure something out.
I'll start pulling this up in the meantime.
Yeah.
All right. So I never told the punchline to the joke from earlier. So how do
it,
mermaids
buddy.
wash their fins? Tide. All right, I'll be here all day.
That's
Wonderful.
encouraging him.
Oh,
That was
man.
physically painful.
I love just like the absolute silence after the joke. Oh,
Yeah, you got to boo. You got to boo in the
I
chat.
got one boo.
I'm just glad you guys didn't
Wait.
bring the tomatoes.
Nick, can you enable screen sharing?
Oh,
Sorry.
of course.
Then I'll go dive into this.
All right. All right, you should be able to.
Sweet. All right, hold on.
American memes are better. Just Eclipse memes in general.
Oh no.
All right. So before we start, I just want to say we're gonna have a pretty short presentation that Jeff's gonna go through, and then we're just gonna open up for Q&A. So if you want to ask a question, you can ask out loud. You can sit in the chat, or you can submit it if you really want to in this Google form that I sent out a lot of places earlier. That basically will put your questions on a list so I can read them out when there's a chance. So I'm gonna send that link in the chat while Jeff is talking. But yeah, even while he's talking, send your questions in the chat if something comes up, and we're gonna get to everything we can, or we will get to everything that's asked by the time we all leave. So without further ado, take it away, Jeff.
Thanks, Nick. All right, well, hello everyone. Thank you for taking the time to come out to Rice Eclipse's new student panel. So we really appreciate you guys taking the time to come out here. This is gonna be like pretty casual. I'm just gonna go through like this sort of like 5-minute, 10-minute presentation just to give you guys an overview of the team and what we do and what we're like. And then we'll just do like Q&A for the rest. Like any questions that you guys have, like please fire away. So with that, I'm just gonna dive right into this. So we kind of already introduced ourselves, but we'll go around and do it one more time, just more formally. So these are the panelists that we have here to answer your questions. So first off is me. I'm Jeff Michelle. I'm the president of Rice Eclipse. And then, like I said before, I'm a senior mechanical engineering major, and I'm also originally from Long Island, New York, so not too far from New York City.
Awesome.
Go around and introduce. Yeah, there you go.
Yeah, so I'm Mike, or Mike Riccardi, if you want to be formal. I am the design lead for Rice Eclipse. I am from New Jersey, so please don't hold that against me. And I'm a rising junior.
I'm Kimberly. I'm the aerodynamics lead. I'm from Venezuela, I guess you can say that. And I'm a rising junior, mechanical engineering as well.
I'm Caroline. I was the chemicals lead last year. I'm a rising junior. I'm a double major in chemistry and history. And I'm from Charlottesville, Virginia.
I'm Anissa. I'm a rising sophomore, majoring in electrical engineering, and I'm the avionics testing lead. And I'm from Pearland, which isn't that far from Houston.
Awesome. All right, so I just wanted to give you guys a quick overview of the team. So this is our most recent team picture. So that's almost all of us out in front of, it's called the ODEC at Rice, the Oshman Engineering Design Kitchen, which is basically Rice's makerspace. There's a machine shop, there's all sorts of tool benches and just things to build and put stuff together. There's a chemicals wet lab, wood shop, all sorts of fun stuff. We basically live in there. That's at least where we have a space set aside for Rice Eclipse. So that's where we do most of our work. That's where we also take our team picture. We're a pretty large team right now. We have over 50 active undergraduate members, also come from a bunch of different majors and backgrounds. We have a pretty wide representation of different majors in the team and just different kinds of people. So we're really happy to have anyone and everyone join the team. So just to give you guys a little bit of an overview of who we are and put some faces to us. In terms of what we do, in a nutshell, we build rockets. So we are Rice University's rocket team. More specifically, we build rockets for something called the Spaceport America Cup, which some of you might be familiar with, but some of you might not be. It's the largest intercollegiate rocketry competition in the world right now. It takes place out in White Sands, New Mexico, every summer. And it's has over 100 college teams from all over the world come and launch rockets in a bunch of different categories. You can see the picture there this is our rocket for this coming year, for this summer. Unfortunately, the competition was canceled like everything else because of COVID-19, but you can see just a picture of our rocket there just to give you a sense of scale for these types of projects. Like that's an over 10-foot tall vehicle with 6-inch diameter. So it's pretty large project and we have a lot of people working on it. And beyond building rockets, you'll see as you sort of get more involved in Eclipse, if you choose to do so, that it's more than just building the sort of rocket itself. There's all sorts of different subcomponents and subsystems and things that our team works on and engineers and designs in order to make this thing work. So that includes things like engines. Like beyond building rockets, we also develop, design, and test our own hybrid rocket engines. I can explain more what that means later if you guys are interested. We also do a lot of electronics, hardware, and software work. So Anissa can speak more to that later as well, but it's sort of all the brains and like the hardware and the software that control engines, that control rockets in flight, sort of more of the software and electrical engineering side. We also do scientific payloads in all of our rockets. So we actually partner with professors and do research, like actual science as part of the payloads on these rockets. So we sort of run the gamut of all sorts of engineering design stuff. We're not just making the outside of a rocket. Like there's all sorts of stuff involved. We also do a lot of other things like sort of outside engineering, like we do STEM outreach events. We also try and work to get sponsors for the team. I lead that side of the team as the president. You can see sort of on the bottom just a general like structure of what Eclipse looks like. So we all sort of are built around trying to build these Spaceport America Cup rockets, but we sort of have 3 technical teams within Eclipse. There's the aerodynamics team, which Kimberly leads, which builds the physical rocket itself. So they do like structures, payloads, airframes, like the physical rocket. We have a propulsion team, which does the rocket engine development that I mentioned. We also have an avionics team that does all the electrical hardware and software work. And then we also, on the non-technical side of the team, we have a public affairs team that does sort of outreach events and marketing, things like that to try and get our name out there and just tell Rice and the greater Houston aerospace community what we do. And we also have a finance team that does things like budgeting and collecting sponsorships and things like that. So if you're more interested in like sort of business development type of thing, then we also do as well. I'll keep going here.
One of the things that we want to focus on, and that we say all the time, and that we really mean it, is that Eclipse is such a huge team. I mean, you saw the picture earlier about all of our members, and there really is room for everybody. So if you want to dive into the hardcore engineering and technical side of things, that's there for you. And if you want to dive into the more public affairs and finance roles where it's not as technical, but you're still doing very important work, that is also a huge part of what we do. So there is room for anyone and everyone who wants to join.
Yeah, absolutely. And that's a good segue into just kind of these important points that I wanted to bring up for anyone interested in Eclipse. Number one, and most importantly, no prior experience is necessary at all to be a part of this team and to contribute to it. I know the stuff that we do in some cases is literally rocket science. And at least for me, when I started on Eclipse back when I was a second semester freshman, it was very intimidating. But I just wanted to emphasize to everyone here that you don't need to have any prior experience in rocketry or in even engineering in general, or just anything to be able to join a team and learn. The entire team is dedicated to teaching you and mentoring you so that you can learn the engineering design skills that you need to succeed at Rice and then beyond Rice as well. That's sort of our core mission as a team, beyond just building these rockets for the Spaceport America Cup, which we'd like to win. We also, like, our sort of main purpose is to try and, hopefully, but we try and, our main goal as a team is to educate our members and teach you guys engineering skills, as well as like public affairs skills, like communication skills, budgeting skills, all those other more life skill elements that are important to being a successful person and a successful engineer. So no experience necessary. When I came into Eclipse, I had zero engineering design experience. I had built like a couple of model rockets, like SD's model rockets, when I was like 10 years old. But like that was all that I had coming into Eclipse. And then I joined as a second semester freshman. I didn't even join in my first semester. And then now I'm here. So like that's just kind of a testament to like how much the team dedicates to sort of teaching our members. I also wanted to bring up that just the time commitment for the team is totally up to you. I think like most things at Rice, like you'll get more out of it the more that you put into it, but we don't require our members to like work for a certain number of hours each week or anything like that. Like if you just want to come by and come to a few design sessions and maybe learn how to do some machining work or things like that, we're happy to teach you, and there's no commitment to staying at all. We just want to teach you guys skills that you think would be valuable for you to learn. So the time commitment is completely flexible and up to you. I also wanted to bring up that Eclipse, like I mentioned before, and like Mike brought up, is pretty diverse in what we do. Like we have teams that do like sort of structural mechanical design. We have teams that do like software development. We have teams that do avionics hardware development. We have teams that do like design like fuel grains, like they sort of design rocket fuel, like design rocket propellant, do all the chemistry of that kind of work. So like there's a lot of different majors and fields that are represented on the team. So use those teams to explore different majors and interests when you come to Rice. Like it's, at least for me, like again, for example, I didn't really know what I wanted to major in when I first came to Rice, but when I joined Eclipse in my second semester freshman year, it gave me the chance to kind of actually do mechanical engineering and sort of see what electrical engineering was like, or chemical engineering, and sort of realize like what I actually like to do. So like you can use Eclipse as a way to actually like do hands-on practical work in all these different fields and see what you like most. And then I also just wanted to say that like the stuff that you'll learn on this team, whether it's like design skills or like leadership skills or like team management skills, things like that will, they're not just applicable to the aerospace industry. Like I know we're kind of a rocket team and most of our members are in some way like space enthusiasts to some degree. But we have like people come into Eclipse who are sort of not interested in aerospace specifically, but they just want a sort of high performance design team where they can hone their engineering skills and hone their team skills and sort of develop that side of themselves as well. So we're a very, very high powered engineering design team beyond being a rocket team. So if you're interested in that as part of your Rice experience, we're happy to provide that as well. Like you don't need to be interested in rockets to join the team and make a contribution and learn something.
Yeah, the engineering program at Rice, it's very robust. The professors are wonderful. But if you really want to just like, you know, sink your teeth into some hardware and like do some real engineering, it's not the only thing we do, but if that's what you're looking for, Eclipse is probably the best way to find it. Because we have such a robust engineering team here on the team on Eclipse. So if that's what you're looking for, then this is the place to be.
Yeah, we are the largest engineering design team, like project-based engineering design team at Rice right now. There are a lot of other teams, and I encourage you to explore them as well and see what fits your interest most. But we are a pretty large team and a pretty established team, and we're happy to take in new members all the time. There's also, I know this is a thing for some student rocket teams, there's like an application process to like get on the team. Like there's absolutely none of that here. Like if you want to join Eclipse, like come join. Like we're really happy to have you. So there's zero barrier to entry is kind of my point. Like, please come check us out and see if you like it.
Yeah, before I joined Eclipse, the only thing that I had done was build, those like marshmallow towers with like the pasta sticks. That's all that I had done beforehand. So there really is no barrier to entry whatsoever.
I'd played like 10 hours of Kerbal Space Program. That was my knowledge.
Yeah, so absolutely just don't be shy about joining the team and just even checking us out for like a few weeks during a semester, things like that. Like, please come by and see if you're interested in it. I also just wanted to play a couple of quick videos here, just highlighting some of our past projects. Oh, is there a question?
I'll be back. I need to do something
Okay.
right now. I'll be back soon. All right, bye guys.
Sure, no problem. All right, so I just wanted to show a couple of videos just to give you guys sort of a sense of the scale of our projects and what we do. Rocketry is sort of an inherently dynamic thing. Like, rockets go up and shoot flamey boom booms out of the bottom. So I just wanted to show you guys some of the things that we've actually built. So the first thing on the left here that I'm going to show you is a hot fire test. So it's like a full ignition test of one of the rocket engines that we have designed, built, and tested from scratch. We call it Titan. It's an 800-pound thrust hybrid rocket engine. So it produces 800 pounds of thrust. It's attached to our mobile test stand, which is it's a trailer basically that we rigged up to be able to mount an engine and actually erect it and then do testing, do hot fire testing like this on it. Ooh, sneak preview. So this is just a video showing a hot fire test that we completed of that engine. This was last April, so a little over a year ago now. Let's see if it plays or if my Wi-Fi dies. Oh, there we go.
Fingers crossed, people.
The sound is going too.
Oh. Yeah, so a fun thing to mention about Titan is that it is at the maximum allowable impulse of a rocket that is designed by civilians. So Uncle Sam himself is preventing us from building a larger rocket. This is the largest that any civilian is allowed to make. If we wanted to build a bigger one, we'd have to get licensed like Lockheed Martin or SpaceX. So that's kind of the size of the projects we get to work on here. And I'm so excited about it.
It is doable to get that license, but it takes some work. So anyway, yeah, just to give you guys a sense of what we do. Like, we build rocket engines, which is not a lot of university student teams are able to do that. So it's definitely not unique to Rice Eclipse, but something that if you're interested in learning about aerospace propulsion, boy, do we have a lot of projects for you. And then I'll just also show, this is a video of an actual rocket that we built. This one is powered by a motor that we bought. It's not one that we've made, but this is our Spaceport America Cup rocket from last year, which we have called Noctua 2. This was a test flight that we did that year.
And so, yeah, like Jeff mentioned, the motor we bought off the shelf, but all the guts of the rocket and the carbon fiber airframe and everything that went into it around the motor was designed in-house. So we have a team that designs the aerodynamics of the fins, and we have avionics that guides the rocket and keeps track of it. And there's a lot of work that goes into it, even though we didn't actually make the engine ourselves.
And it's very common to not be able to see the rocket for a solid few seconds.
Yeah.
Yeah, I think the rest of this video is us desperately trying to find this rocket in the middle of the blue sky. So I'm gonna leave it there, but I think that went to about 9,700 feet. That was about a 10,000 foot flight. So beyond building big engines, we also build rockets that go pretty high, which is fun. And then just to give you an idea of kind of what we're gearing up for next year, we are, so the main thing that we're doing is we are building our 4th rocket for the Spaceport America Cup. So this is for the 2021 competition. So next summer, not this summer. And this rocket will go to 30,000 feet. So this rocket will go over over 5 miles into the sky. It will also break the sound barrier for the first time of any rocket that we built, which adds all sorts of fun design challenges and is also pretty cool. So we'll get an Eclipse sonic boom. And this one is also going to be powered by a commercial solid rocket motor that we purchased. So a solid rocket motor, for those who are not familiar, it's like the space shuttle solid rocket boosters on the side. Like it has only a solid propellant. There's no liquid fuels or oxidizers involved. But anyway, yeah, so that's going to be a pretty big project and it's very, very exciting. And that's what Kimberly is going to be leading up over on the aerodynamics team. So if you're interested in that kind of thing, absolutely come check us out. We are also in the middle of, we just finished the design cycle, or we're finishing up the design cycle for a new hybrid rocket engine that we call Titan II, which is the second iteration of that large Titan engine that you saw hot fire of. This one is optimized for flight. So we will be integrating this rocket or this engine into a rocket that we build and flying a rocket at the Spaceport America Cup for our 5th rocket, so the one after this year. That will actually be powered by our own engine, which will be a really big milestone for the team. And we're about to dive into actually manufacturing this engine and doing testing. So that's going to be a very exciting phase of this project. So again, if you're interested at all in propulsion, or you just want to learn a little bit more about like rocket engines, like it's going to be a really exciting year. I also wanted to bring up that beyond all these projects, we also do what's called a certificates program for high-powered rocketry. So if you join Eclipse, you can actually build a rocket to get certified by a national organization called EEE Rocketry to be able to purchase larger solid rocket motors to fly in rockets. So there are different levels of certification. There's level 1, level 2, level 3, which let you buy larger and larger rocket motors. And as part of an Eclipse team, you can build a rocket to get that level 1 certification, which kind of gets you in the door of the world of high-powered rocketry. So even it's a really good way just to kind of like build like a rocket for yourself, just like your own rocket, not just like a very large competition rocket, and learn the basics of like how the rocket works and the recovery system, the engine, things like that. So it's a really good program just to kind of build a rocket and learn. So that's something that a lot of our new members are very, very interested in doing. Kimberly, did you have something to say? I thought I heard someone speak up.
Like to get a sense of the size of it, it's that green rocket. I don't know if Jeff mentioned that. Like that green.
Oh yeah, sorry. I have my Zoom thing covering the picture.
Like certificates rocket would look like, and like the majority of our members make one, and you get to keep it afterwards. So
for a really good sense of the size, we're the same height.
Wow.
Yeah. So like it's a really fun program, and most of our members.
I have the card right here. Actually, it's fun to be able to carry around like the actual like high-powered rocketry license just like in your wallet. So
yeah, you get a fancy card, and it lets you so it lets you sort of buy these larger motors. And if you want to get involved in rocketry outside of Eclipse at all, like that's sort of the first step into the world of like larger rockets that are not like sort of Estes level, like sort of smaller model rockets that you can like buy in a hobby shop. So that's also a really fun program that a lot of our members get involved in. We're also diving a lot into avionics projects as well. So we are putting together a new software program that the avionics team has written on their own to conduct engine testing. So to collect data and control all the components of like a hybrid rocket engine during a hot fire. We're also working on some projects to do real-time data transmission from a rocket in flight, which we call our real-time rocket project. So there's a lot of sort of hardware and software projects going on there as well. So if you're more interested in, or you think you might be interested in electrical engineering or computer science or fields like that, those are also very good things to get involved in. I also wanted to bring up, like I mentioned before, that we do a lot of work with different professors, and we fly research scientific payloads every year in these Spaceport America Cup rockets. It's part of the requirements of the competition. So it's a good way to build relationships with professors, sort of working on projects with them through Eclipse. They're also great mentors to us because we come into a lot of pretty challenging design problems on the team, because it turns out that rocket science is kind of hard actually. So they're very, very helpful whenever we run into like a complex problem. We definitely reach out to Rice professors who are more than happy to help us with these projects. And they're really excited to see us actually trying to dive into these design challenges. So it's a good way to build relationships with there too. And we'll do a lot of other things too beyond this. I just wanted to give you guys a flavor of what's coming up for next year. Sorry, go ahead.
You mentioned this kind of like, it's kind of the avionics like analogous, I guess, certificate you can kind of think of about getting like just right off the bat. I know a lot of people in Eclipse are interested in studying for your ham radio license. So that's like another thing that you'll find a lot of support for here. I'm plugging it while I can. I know I've been studying for a while. I should just really gear up and take the test, but I haven't. But you'll find like a few people have been studying. And that's so you can operate like a ham radio license. And I think of it as like the equivalent of the cert for like buying more powerful motors. But
yeah, totally.
And so to be clear, none of this is required. You don't have to go for your L1 or the ham radio license, but they're just fun things to do, and you get to do with a lot of fun people. So if those are the kind of things that you're interested in, there's definitely room for you on Eclipse.
Yeah, and we also don't just do technical work. Like I know I've been throwing a bunch of technical stuff at you, but we are all like pretty much friends with each other, and we do a lot of social events on the team. Every year we do like a team cookout, like a barbecue, s'mores nights. We do space movie nights in the ODEC as well. Every single like sub team on Eclipse, like the more specific teams, I didn't really get into in this presentation, but we can go into more detail later. But they do their own social events, whether it's like off-campus dinners or other movie nights or things like that as well. So it's a really fun community. Beyond just being a place where you can learn a lot of pretty awesome engineering. Like I know that some of my closest friends at Rice have come through this team, both from working on the technical projects, but also just the fun stuff that we do when we're not on the clock, so to speak. So it's definitely a good way to make friends at Rice as well, or just get to know people who are interested in space flight or engineering or design work or things like that. So if you're interested in finding a place at Rice for that as well, we're definitely a place for that. Sorry, go ahead. Yeah,
that's probably one of the best parts of the club is that if you go to the ODEC at any time of any day of any week during the semester, there's always something Eclipse related happening. And so if you're just like looking for someone to hang out with or something to do, just roll on up to the ODEC and I guarantee somebody's there. It's a lot of fun. And there's never a shortage of things to do.
Yeah, I guess the last thing I just wanted to bring up is just sort of the network that Eclipse has built up over the past 5 years or so of its existence. So this is just a list of different organizations and companies and graduate programs that Rice Eclipse has sent its members to in the past, whether it's internships or full-time jobs. We've pretty much sent people to every major aerospace organization in the United States right now. We actually just had one of our members pick up a Blue Origin internship as well. So I think that truly completes our list of pretty much everyone. And also we've sent a lot of our members who are interested in graduate school onto some very, very top-notch graduate programs as well. For master's degrees and for PhDs for those who are interested in that. So if you're interested at all in working or doing an internship at any of these places, Eclipse has sent people there in the past, and it's the current members and the alumni are very, very supportive in trying to help Eclipse members get positions, get internships, get jobs in these places because they know what the experience of Eclipse is and the value that it brings and how useful those skills are to places like this. We've also sent people to places beyond aerospace as well. Like I mentioned, if you're just interested in learning about engineering design and you're not really interested in aerospace specifically, like you'll still learn a lot here for sure. And there are people who have worked on Eclipse and then have gone to work for, let's see, I'm trying to think of a few, like they've gone to work for energy companies, they've gone to work for different engineering companies in Houston, for software engineering companies in Silicon Valley. There's sort of a lot of different places where members have gone. Was someone else? I thought I heard something in the line.
Also like GE healthcare. So like something not very relevant to aerospace, but still.
True. Yeah, so I think that was pretty much everything I wanted to cover. So thanks for listening in on that. It took a little bit longer than I thought, but if you guys have any questions or want to learn more about anything in that presentation or other questions, please fire away.
All right, so I'm looking. Oh, Nick, do you want to take it away?
Yeah, sorry. I just want to say that this Q&A session lasts from now until the heat death of the universe. Well, again, but basically everyone will be here till 9, probably regardless. But like, if for some reason it goes on, keep answering questions. If you ask a question, it'll get answered. So pretty much just speak up if you want to ask a question. If there's an awkward amount of silence, I'll read one from the chat or from the list I have, and we'll just chug through them.
All right, it looks like I'm looking at the chat, and Austin Lee has asked, do you cook the food at the outings with the rockets? And to that I say not yet, but we are working on it. So one of the things that we want to do is we want to, because when we're doing these tests, sometimes there's a good bit of setup that happens. So we're trying to get a grill so we can just like take it out with us to the range, and throw some food on the grill, some shrimp on the Barbie, if you will.
And Mike, I believe he was you misread the question. He was asking, do you cook the food with the rockets?
Oh, do we use rockets to cook the food?
And there's some plans, but that I'll leave it at that.
Don't tempt me.
Yeah, don't tempt us.
Yeah, it's sort of a running joke that one day we'll put a kalachi in the flame diverter of one of our engine tests. That has not happened yet, so I can't say that we have not cooked food with our rockets, but after every launch or during a launch, most of the time it's sort of after the launch, we do go and sort of get dinner or like late lunch as a team. So there's sort of that social element as well.
Wait, I wonder if the combustion chamber gets hot enough to cook some bacon.
Probably.
Like you can't touch it with your hand. Like I wonder. Yeah, we definitely could.
Okay, so I'm gonna stop you right there. We have a lot of questions.
Let's keep moving through these.
But I would like to say to y'all, this is the exact kinds of conversations that happen at every single meeting. No matter how serious we try to make the meeting, at some point, we start talking about bacon on the combustion chamber.
We go down many rabbit holes.
Let's see. So Evan's question is, can we get more in-depth explanations on like each lead in the hierarchy of the club? That's a interesting question, but I was thinking we could answer a few of the shorter, quicker ones first, because that's a bit of a rabbit hole.
Yeah. Okay, that sounds good. Yeah, that's a very good question, Evan. But yeah, we'll go into the hierarchy for everyone's benefit, but that will take a little bit of time. So we'll go through the shorter ones first.
Just a little bit longer. It is a really big club. That's something that you need to know. It's big. So the two related questions is, would you call Eclipse a major commitment, and what's the time commitment like?
It really can be whatever you want it to be. I know some people sleep in the OEDK and some people turn up like maybe once or twice a month or once or twice a semester. But like if you get really interested in something or just one project, you can spend as much time on that as you want. Or if there's areas you're less interested in, you don't have to show up to every meeting, especially like around exams or if you have other commitments. We're just happy to see you.
Mm-hmm.
Yeah, and I mean, like, a big thing is like we're all students, right? Like, this isn't a job, like this isn't a class. Like we're all here because we like love what we do, and I really enjoy every single minute that I spend on Eclipse work. But at the same time, we're all students, and like if you have a test in 2 days that you're really stressed about, or if something comes up, no problem, it's totally fine. This is not in any ways mandatory ever. So if you need a break for a semester, or if you need a break for a week, go ahead and take it. It's not a huge deal.
I would also say that it's kind of important, like you can distribute your time the way you want to. Like it's not like, oh, if I'm gonna work this many hours a week, I have to like do like it all during the weekdays. Like for me specifically, I would say I spend a lot of time on Eclipse, but I kind of made it to the point where like I could just spend like whole week on weekends on Eclipse, but my week would be pretty light with any Eclipse work.
Yeah, so there isn't really a direct answer, which is just because it's totally flexible and up to you. Like you can come when you want to, you can do as much time or spend as much time with the team as you want. It's not like there's a requirement that you do like at least 10 hours a week or 20 hours a week of work on Race Eclipse. So it's entirely up to you. And some of our members end up spending so much time that they do sleep in the ODEC, and some are a lot more casual, but all are like totally equal and valid members of the team, and we appreciate all their contributions. So like, don't feel bad about if you just want to come by once a month, or if you just want to even see in your first month at Rice, or just even like, for example, with me, I joined in my second semester. Like I didn't even like come across Rice Eclipse until halfway through my freshman year. So like, if you just kind of want to check it out and like leave after a month because you realize it's not for you, or you just like your first semester, you don't feel like you have the time to do it, like that's totally fine. And then if you want to come back later, we're happy to have you, just whenever you want, really.
Wait, real quick, Jeff, do you want to stop sharing a screen?
So yeah, I could, or we could leave it up for the.
So they know who's who.
Oh yeah.
Yeah, I think it'd be good that we could leave it up so everyone just kind of knows like who we are.
You're right. My bad.
So if you have a specific question, you can ask any of the panelists, like them specifically, because we've got Caroline, who's from propulsion, Kimberly from aerodynamics, and Anissa from avionics. So if you have any special interest, just ask them specifically. The next question is, what role would an astrophysics major play on the Eclipse team?
That's a very good question. So I will say that we don't do any like astrophysics observation or astronomy observation necessarily on the team, just because we're more putting together hardware. But for example, if you're interested in sort of astrophysics or astronomy and sort of in those fields, a lot of things that you'll be working on is developing like scientific payloads and designing instruments and things like that to be able to collect data for like astrophysics experiments or things like that. We have like our payloads team on within aerodynamics that builds the scientific payloads that go into our competition rockets. So in the past, like for the past few years, they've been more like mechanical type experiments. But in the future, like that payload can literally be anything. So like, as long as it's doing some sort of science. So if like that's a very good place to learn about like some of like the electrical work and the mechanical work that goes into just like making a payload, which is like, it's not like direct like astrophysics. Like you're not learning necessarily like the dynamics of like star systems, but you're doing sort of practical design work that is definitely applicable to that field. So that's one place that you might be interested in if you're more along the along like the observational like astronomy sciences type thing. But also like you can just feel free to explore the different teams on Eclipse and see if there's anything else that's interesting. Like there's a lot of people, like a lot of people on Eclipse who just kind of like, they're interested in like some electronics work, so they can go over to one of the teams that does more like electrical hardware development and just sort of experiment with that for a little bit. So even though we don't like directly do astrophysics, like it's a good way to just learn some of the like engineering work behind it. That would be very helpful. And also we definitely have like a lot of like astronomy and astrophysics, like interested people on the team, just because a lot of like space enthusiasts kind of like, there's kind of some synergy there. So it's also a good community of people who are interested in similar things.
And you get taught everything you need to know to do any project on Eclipse. A freshman Mechie knows the same as a freshman English major. So don't let your major just, make you decide what to do.
Yeah. So like last year I was leading like a team that was like very stereotypically Mechie, so like mechanical engineering, and yet I had like a computer science like a major in the club, and like he excelled basically, like, and he got so into it and passionate. So like, don't necessarily let your major dictate what team, because you could just end up being interested in something different.
Interesting question. Austin Lee asked what our mortality rate is. To that I say
Zero,
no
as far
comment.
as the feds know.
Zero
No
mortality
comment.
rate. What I will say is that we have someone named the Chief Safety Officer who oversees all the safety operations of the club, and they make sure that everything that we're doing is sound, both on the engineering side of things and the safety. So it's very safe. We haven't had any major incidents recently.
We're extremely cautious.
Recently.
Yeah, so like
we have in all seriousness, that's not something I should have made a joke about it. In all seriousness, we haven't had any incidents. No one's ever gotten hurt. Everything's fine.
yeah, like for Eclipse projects, like we've had rocket engines that have blown up on the test stand. We've had rockets that have failed in some way or had an anomaly during launch. So like just because we're doing like real engineering work, like part of that is failure, and there's iteration, and you're going to make something, it's going to break, and then you go and make it again and make it better. So like we do have situations where there are hazards involved in the testing that we do, but sort of like Mike said, we like sort of as a very serious note, like we take safety extremely seriously on Rice Eclipse, and we have an entire officer, like a highest level leadership position on the team, who is the chief safety officer, who goes through our procedures and does risk assessment and make sure that our tests are safe. We also work with Rice's environmental health and safety administrative group to make sure that what we're doing is again safe, and we're not accidentally doing anything or conducting an operation that could be hazardous in a way that we don't realize. So if you join Rice Eclipse, like please do not worry for your health. Like we
guarantee your safety.
Yeah, we have a lot of protocols in place to make sure that the testing that we do is safe. Just like, again, like rocket science and engines and rockets are dangerous to some degree, but that's something that we absolutely consider. We're not just, believe it or not, we're not just a bunch of people blowing up rockets in our backyard. Like,
as much fun as that would be, if we can't do something safely, then we're not going to do it. Yeah, and that's just that's it.
For sure. So 0 mortality rate and 0 like major injury rate. We've had some people get cut on like a bracket before. Like people have shed blood, but it's not blood.
I cut myself on a tape measure.
There we go. So we've had some first aid events.
Batteries and irons are hot, can confirm.
It was worth it though. I got some awesome measurements.
Okay, wait, maybe this isn't what we want to tell the new members.
Oh God, Austin, no. All right, so as long as you guys do not tell the Rice administration about that,
don't tell admin, please.
Anyways, all right, so I'm gonna get a couple from the anonymous questions list. 3 related ones is basically about company sponsorships. So it's like, do companies outreach to members of Eclipse, or are there any companies that are looking or possibly to sponsor Eclipse?
So yeah, every year we have different companies that come and sponsor Rice Eclipse. Like it sort of varies from year to year. In the past, we've had, for example, Blue Origin sponsor Rice Eclipse. We had Planetary Resources sponsor Eclipse before they kind of died as a company, but they were an asteroid mining company before they went bankrupt, which is really cool. We get a lot of grants from Rice University, from the ODEC, from other places like that. But we also have companies that, like, for example, where our members who have done internships, they sort of ask to come and speak at our general meetings, and like they're interested in potentially hiring some of our members. So sort of like by sending Eclipse people to these different organizations through internships and full-time positions and things like that, we're able to sort of bring these companies into Eclipse, and they're interested in hiring our members. Like at least like it's not a guaranteed job or a guaranteed internship or anything like that. Like I don't want to overblow it, but basically we can get your foot in the door because we have alumni who have been through Eclipse before, and they can give you a pretty solid recommendation to be able to get into a program.
Hey, Jeff, yeah. Real quick, my memory's a little fuzzy. You got an internship, right? Where did you go?
Yes, so we have currently 5 people on Rice Eclipse, myself included, who are part of the co-op program at NASA's Johnson Space Center here in Houston. So we have 5 of our members currently bouncing back and forth between Rice University and Johnson Space Center here in Houston, taking semesters off to come work. So for example, I'm currently working this summer in the propulsion testing branch over at Johnson Space Center. So firing off RCS thrusters, so like thrusters for lunar landers and stuff like that. So we've, if you're interested in Johnson Space Center in particular, the sort of local NASA center here in Houston, they've sort of realized that we exist and are now pulling our members left and right into that program.
Yeah, it was funny. We were like taking a look at like the incoming like class of like leads and officers for next year, and people kept getting pulled by NASA. We're like, God damn it, NASA! Why are you doing this to us? We need these people. But no, in all seriousness, we're very proud of our members and like what they can accomplish. Yeah, I think we have a very bright future ahead of us on that front.
Yeah, so another question on the list was, will this help if we try to get a NASA internship? And so I think y'all answered that question.
Yes. We've had people beyond Johnson Space Center. We've also sent, I believe we've sent 3 of our members to the Jet Propulsion Laboratory, so the JPL out in California and Pasadena. So they do like the Mars rovers, for example. There's also a Rice alum there who's very, very active in pulling Rice students into that internship program. And obviously Eclipse looks very good on our resume if you're interested in working for the JPL. So not just Johnson Space Center.
So yeah, before we do the next question, I do want to mention that there's a few of you guys who have great questions that are very technical. For example, our thoughts on aerospikes.
Come on, I wanted to talk about aerospike.
No, let me finish, Mike. Let me finish, Mike. I should also mention, guys, Mike is my boss this year, so you know that this one.
No.
Like talk more about our Titan II engine and a few other things. We are going to talk about that, and we love talking about that, but we're going to want to save those for later on, like answer the more conceptual information stuff, and then we can all chat about rockets and stuff.
Okay, that sounds good to me. Yeah.
We will get to your stuff. I'm going to bounce to the Eclipse, to the Zoom chat. How well would working on aerodynamics at Eclipse transfer to other form of aerodynamics, like race cars, for example?
Yeah, so right off the bat, I think that like the airframe subteam would be pretty good for that. So the airframe subteam is basically, so I say subteam as in there's no better word for it, but a subteam of the aerodynamics team. But so what they do is they design like the general like outline of the rocket. So like they say what size and shape the fins are, like how long are each body tubes, like what nose can they use, etc. And part of that design process, what they do is a lot of like modeling, so like fluid flow simulations. So right off the bat, I think that like that would be a good application. Like you got to do the same thing for like cars, like race cars too. If you're not really looking for like design or like simulation, then really any other team like does machining and like the Eclipse as a whole like designs components, and these are like tools and skills that you apply in any like engineering internship. But yeah, so like specifically airframe if you're looking for that simulation front, but really any subteam.
I will say that the nozzle team is using ANSYS, which is a commercial grade simulation software that we got access to through our connections with professors. And that's what's used in industry every day to design rockets and planes and sports cars. So if you're looking to get some experience using industry grade tools, that's also.
Oh yeah, like airframe uses it's also commonly used.
I mean, yeah. There's a lot of different.
It also depends because like airframe is on the rocket, like the rocket itself side of the club, while nozzle is in the propulsion side of the club.
I think now would be a good time to give everyone a quick overview of Eclipse's org chart as well, just because we're kind of getting into like technical nitty gritty a little bit.
Yeah.
I was trying to look for we have like an organizational chart, but
I've got it pulled up actually.
Oh, perfect. If you could pull that up, Nick, that'd be great. But I'll just.
Yeah. So very, very quick overview. I know it's not going to be very clear for y'all, but so up here you've got the president here, which is our boy Jeff. The president oversees secretary and treasurer, which are that's an outdated subteam name. Now they're the chief financial officer and the public affairs officer, and they manage their own subteams. The vice president/design lead is what Mike is, and they oversee the technical aspects. We have the safety officer, And then what we've been talking about is aerodynamics, propulsion, and avionics here. As you see, under each of these 3 teams, there's a bunch of sub-teams. Each of these sub-teams has their own lead, their own group of kids, and their own major projects they work on. There's a huge amount of different opportunities and groups here. And another question that we haven't got to yet, but I might as well do now, someone asked was, how many people per sub-team? Can you be on more than one? You can be on as many sub-teams as you want. And the number varies.
And especially as new members in particular, we encourage you to try out different teams. Like you can be part of the composites team on aerodynamics, which actually wraps carbon fiber to make our airframes, like to make our body tubes for our rockets, for example, and be a part of the chemicals team on propulsion, working on the fuel grains for our hybrid rocket engine. Like you can absolutely do multiple teams and see what you like most.
Yeah, and
or just be involved in multiple.
We highly, highly, highly encourage you to reach out to as many sub teams as you can to get a feel for their in particular field and the projects they work on, because there is room in Eclipse for everyone, and we're not kidding. There are so many different teams and so many different areas to get involved in. And so we really do encourage everyone to try them all out and see which one fits best for them.
Yeah, also, again, would like to emphasize that this is pretty outdated. Like the non-technical side has been, like it looks completely different now. And as for aero, prop, and avionics, they all have, I think they all have one more like sub-team.
Yeah.
Yeah, we haven't put together a chart for this year yet. We added some teams and made some changes because the team has grown and has new needs. But this just gives you a little bit of an idea of like the names, at least, of the teams that exist. And I don't think we really, if you guys have any specific questions about like each of these teams and like what they do, like please ask in the chat and we'll address it. But just because we have a lot of questions to get to, I don't think we're going to go through and do like every single team type thing. But if you have any specific questions like about any of these, like please let us know.
I'll keep that pulled up. All right.
While we wait, I want to add to Josh. Justin is great. We love him. I love him. He's an aero person, but
yeah, Josh is fantastic.
Josh is amazing.
Justin.
And Justin.
Yeah.
Both
of them are wonderful.
All right, so the next question I want to do is, where does your annual budget come from? How large is it?
That is a great question.
That is a great question.
I'm wondering that myself.
So our annual budget on Eclipse runs around $10,000 a year, but it varies depending on the needs of the projects and what we're doing each year. And our budget, like I said, comes from a bunch of different places. We have some companies that directly sponsor Eclipse through alumni or just our own outreach. We also have a lot of grants that come to Eclipse from different organizations within Rice. So, for example, the Rice Engineering Alumni Organization gives us money every year. Let's see, the ODEC, so like the Makerspace gives us money every year. I saw someone had a question about the Rice Space Institute. Rice does indeed have a space institute. To answer your question, it's led by a wonderful professor named Dr. David Alexander, who is a really, really awesome guy. And yes, they are a sponsor of Eclipse. They do provide us some funding every year as well. And we don't directly work with them per se to answer the other part of your question, but they do have different like aerospace outreach events that go on, like they try to get volunteers for conferences and things like that. And they're trying to sort of coordinate like more just sort of outreach and other events sort of like for all of like, for different teams at Rice that are interested in aerospace. So we're getting more and more involved with them as time goes on. They're sort of like, it's more like volunteering work right now, but we are involved with them and they do sponsor us.
Yeah, Rice Eclipse is an independent club, but we do have some very close relationships with, the wonderful Dr. Alexander, who we just cannot say enough good things about, and really a huge spectrum of Rice faculty. They're very supportive and very helpful. We really love them all to death.
What are some of the examples of the work that avionics does?
So I'd say avionics does like you can kind of split up the work into hardware and software, and that's how you kind of split it up for every project. We have several ongoing projects at the moment. I'd say for like big picture work, we do some printed circuit board design and a lot of data collection and communication for like the sensors that we use to like measure our rockets during test and stuff like that. There's also some graphical user, sorry, I'm trying to talk about software a little bit first because I know less about it. I'm a EE. But yeah, so there's a lot of data collection that goes on and trying to put the data into like a nice graphical user interface that's really intuitive with like graphs and charts that show us really what's going on with our rockets. And then for hardware, I can answer a lot better on this one. I'd say we do like a lot of industry relevant stuff. We do printed circuit board design. So like when you think of those, sorry, just in case like anyone needs like base level, when you think of those green boards you find inside of like electronics and stuff, those host all of the components and all of the like traces between the components you need for an electrical device to work. And we do that, which I thought was really cool. I don't have much experience using like my Eclipse knowledge in industry yet, but I worked at JSC as an intern for 2 summers before this, and I was like really excited to find a place that I could apply my printed circuit board design on Eclipse. Like it's really relevant, and I didn't know I'd find that in college, so it was really exciting.
And that's Johnson Space Center, right? JSC?
Mm-hmm. So I think it's really relevant to that. I know we talked a little bit about how relevant Eclipse's propulsion and aerodynamics were to real life rockets, but I just kind of wanted to plug that for a second. You work a lot with like power and communication protocols here too, which I did work on in JSC, so it's really relevant there for hardware design. And some of the projects we're working right now are like a box that kind of a box for our testing thing that works to collect the data for the sensors we put on the rocket and ignite the rocket. So that's really cool. That's one of the projects I'm working on at the moment. So yeah, sorry, I think that was under 60 seconds, Nick.
No idea what
Nick's cracking the whip.
I am doing no such thing.
She's gonna start playing like the Oscar music, like
just slowly start fading down your volume. But no, it's fine. All right. So, can people who aren't doing a STEM or natural science major join, and what sorts of roles are available, if so?
Yes, absolutely. So, like we were mentioning before, sort of the non-technical side of Eclipse is growing, especially for next year. So if you saw on the organizational chart in the past, we used to have the president sort of doing like more administrative and executive work, and then like the secretary and the treasurer who were doing like budgeting work on the treasurer side, and then sort of like outreach and some media events and things like that for the secretary. But we're actually formalizing those positions like much more rigorously this year. So we're going to have we have now a public affairs officer and a chief financial officer. So for like the public affairs side of Eclipse, if you're interested in communications or marketing or branding or even like scientific like writing, like technical scientific writing for like science communication, we have now a sub-team, like an entire team under the public affairs officer who is doing that kind of work to sort of promote Rice Eclipse and sort of explain what we do to different Rice organizations so we can help build our relationships with them and potentially get different funding sources as well. So there's sort of that side of the team, which is like scientific communication and like branding and things like that. That's like non-technical, and if you're interested in that kind of work and doing it for like a more technical organization, then that's a perfect place for you. And then we also have, like I said, the chief financial officer who is going to lead an actual finance team this year, which does sort of like, so they do internal budgeting and procurement. So if you're interested in like accounting or like sort of internal like money management type stuff, like that's a big need that we have on the team. I think compared to other clubs, like we just buy the most stuff out of like any club at Rice University. Like we're constantly buying parts. And it's
not even close. It's kind of, yeah.
Yeah. And then we also have we're going to have people on that team doing outreach to sponsors. So that's it's pretty similar to like pitching for venture capital, for example. Like, I mean, we don't exactly have like a business plan as a team, but like you're pitching Eclipse in order to get funding and sponsorship from different organizations. So if you're interested in finance or economics or like venture capital or things like that, that's a place where you can exercise those skills as well. And those are two areas, like public affairs and finances, where we need people, like we desperately need more people to join those teams and build up those teams. Because as we've grown, we've realized that those are sort of underserved areas of the team that we need to have happen in order for the technical stuff to work. So those are very, very big non-technical things you can work on. And also, if you're not interested, oh, sorry, I just have one more point. Like if you aren't interested in, if you aren't interested in technical work and you join the team as a non-technical major, like feel free to also try the technical stuff and see if you like it as well. Like we don't want to sort of pigeonhole you immediately. Like you're welcome to try anything on the team, but just know that there are those organizations in Eclipse as well that are entirely non-technical in nature as well.
Yeah, we have so many like incredible projects for the public affairs officer and the chief financial officer for next year. And we're really excited to get started on those. And we need manpower, really. And so if you guys are interested in those, and you want to take a deep dive, that's the perfect place for you to go. Because we have a lot of exciting things coming down the pipe. You know, we have grant proposals. We're trying to see if we can host conferences. We have so much cool projects that we're working on. And so if that stuff gets you excited, please come out. We're trying to see if we can get Red Bull to sponsor us. I think that'd be hilarious if we had like a rocket that was like shaped like a giant can of Red Bull. But nothing serious has happened on that front yet, so I don't want to promise anything.
That would make the aerodynamics team very mad.
Yeah, yeah, right. No nose cone. But yeah, there's a lot of really cool and really exciting non-technical projects that are going to happen next year, and so we're really, really excited for that, and we hope you guys will be too.
How can you describe, I'm wondering, the typical first day, how things are divvied up and what sorts of jobs are assigned?
All right, sure. So one of the things that we do is we start the year with the Mini Rockets Challenge. And so that's for, it's kind of just a social thing to kind of get to know everybody and to get some, experiences like meeting everybody in the club. And so we have all the members make a little mini rocket, and it's the engine's about the size of a AA battery, for some context. And they fly up about 150 or so feet. And we have everybody, make their own wings, and we 3D print them, or fins, sorry, and we 3D print them. So that way you guys can get some experience, with SolidWorks, which is the software that we use most of the time, and 3D printers. And then in terms of how things get divvied up, like beyond that, we have a general meeting to introduce all of the teams, all the sub teams that are on the club. I would go through the list, but there's a lot of them, and I'm getting close to my 60-second timer. Yeah, what's up?
I'd like to add something real quick. So I think this is maybe an important place we could emphasize the no technical experience necessary. I know that a lot of our leadership positions put a lot of hard work into introducing workshops or certain meetings that happen at the beginning of the year, really to introduce you to beginning programming or beginning hardware design. I'm sure equivalent things go on in propulsion and aerodynamics, but I've been having a time with abstraction right now. So, but yeah, so some of those first meetings could be introducing you to softwares we're using and stuff, and projects we already have going will give you an outline on, if you want to join them, what they basically are.
Yeah, and so then we have a broad variety of new member projects that are exactly tailored to doing that, of just introducing you to the tools that you need, to really dive in. And then from there, it's whatever you want to do. The way things normally go is that, whoever the sub-team leads, they'll just talk about projects, and then whoever wants to do them does them. So it's however you want it to be divvied up. And the jobs have such a huge variety that it's hard to speak about them in general.
The next question is how much data science plays into Eclipse. And this is one of the more interesting parts of Eclipse because there's a lot of crossover between the teams. And I think there's a great opportunity here. Share my screen and say to meet Luna, which is what we actually do data analysis on. And I think some of the older Eclipse people here have had a lot more experience with Luna. You guys.
Yeah, so for some context, this is beyond that large hybrid rocket engine called Titan that we have. We also have a much, much smaller rocket engine that we test a couple times a semester that we call Luna. This thing produces about 50 pounds of thrust, so it's around the size of like a thruster, basically. But we use it as like a miniature version of our larger engines to experiment with sort of different component designs and just kind of see how they work. And one of the very important aspects of that team is actually collecting data and using that data from tests to like see how different design changes have affected the engine and things like that, so that we can inform our bigger engines and how those designs work out. So especially this coming year, we're really trying to push to have like a very rigorous like data analysis component of the team that runs this engine, which is the Luna team, which is also the team that our very own Nick S is co-leading. So if you're interested in sort of data science, we have a lot of like sort of data analysis work to like process the data from our tests and actually like draw conclusions from that that's helpful from a design standpoint.
Thank you. Here's a fun one. Are there any residential colleges where Eclipse members seem to be more concentrated? Is it super spread out? Which teams?
Oh boy.
Okay, it's a two-part question. First, address the college one.
All right.
Okay, so the administration goes to great lengths to make sure that all the residential colleges are just a perfect cross section of the Rice community, and make sure that it's really random, like totally random where you end up. And so we have representation from all of the colleges very strongly, and we love all of the colleges equally. They're all wonderful, and we have great members doing great work at all of them. That being said, I would be lying if I did not tell you that Lovett is overrepresented. And so Lovett is one of the colleges, and it has much more than 1/11th share of the students.
Raise your hand if you're from Lovett.
Yeah. The reason I just want to say the reason for this is only because in the past Eclipse's recruitment has mainly been from O-Week advisors.
Yeah.
Recruiting kids during O-Week. And so early, the club's really young, like as I mentioned, we're like 5-6 years old. It started with a group of Eclipse people, and it just kind of became a loop over time. But right now is our chance to break that.
Yeah, so in the chat, hey, Chloe, do you mind turning on your camera real quick so the new students can see you?
I'm just here to learn. I just want to know more about Eclipse.
Yeah, it's just we have the Lovett president with us tonight.
Yeah, for those who are not aware, Chloe Awani is.
I figured that there's so many Lovetteers in Eclipse. I might as well learn more about the Lovett community through this platform. So thank you. This was very informative. I really appreciate it.
Yeah,
I would like to point out and point and laugh at Hannah, who answered Chloe's question.
Yes, thank you, Hannah. Thank you for being a very, very helpful person.
Very nice.
But yes, for those who are not aware,
you thought too good of us. You thought too well of us, Hannah.
Yeah, so Chloe's not. Chloe could join Eclipse if she wants to, but she is also the president of Lovett, and she's hanging around right now. But
I have to go, but this was really informative, y'all. This is like one of the best things I think everyone has done, or through the quarantine. Like, you guys have done a really good job. So kudos to Eclipse.
Let's go,
thanks, Chloe.
Thank you.
Thank you, Chloe.
Back to the programming. This is a great question here. Oh, the second part of that question, probably referring to when we were talking about the team structure. What teams have been added, and can you give a couple-word summary of each team?
Okay, so sorry, go ahead, Kimberly.
I think earlier we said we were going to skip those kind of questions, but I don't know if you guys want to talk about it now.
Describe each team real quick. We can give a 3-word summary.
Oh, that's tough.
Yeah, that's probably a bad idea.
In terms of the new teams, I can say so. Like beyond, there's like now a public affairs team and a finance team on like the non-technical side, and then for aerodynamics, Kimberly, could you just go over like the new teams that we have, and maybe just quickly what each team does, like very, very short.
Okay. So the new sub-team is launch rail. So what that basically is, for the propulsion side of the club, when we integrate their hybrid engine and our rocket, like we need some, like if you guys saw the video, you'd see like this essentially a pole where the rocket guides itself on. That's like where it launches off. That's the launch rail. We're basically going to be building our own one for the Titan airframe. I think it's going to be about 50 feet. So right now it's like in the design process. You'll be helping out design and then later on machining. There's also airframe, which is general design of the rocket. So like the layout, shapes and stuff. There's composites, which is the carbon wrapping. There's structures that does like any internal structures that the rocket may need, which includes a motor recontainment system. There's payloads, which works on the research payload, and they're the ones doing more interaction with the professors on like in their labs. There's, what am I missing? I feel
recovery.
Like I've just forgotten her kids right now.
Recovery.
There's recovery. They're in charge of, so we have made our own ejector. We made our own like device, our own like parachute deployment device. It's called the ejector connector. So they work on the development of that and like testing of that and the improvement of it, as well as like general parachute like calculations and stuff of the like. And I think I covered them all.
And Caroline, can you do propulsion?
Oh dear. So
You want me
there's.
to?
Or Caroline and Mike, can you both just go over propulsion?
Sure. So do you want to do the new teams first?
Yeah, sure. So our new team that we're very excited about is the ground systems team. So that is encompassing all of the ground hardware that we use. It's very, very essential for our testing because over time the systems got more complex and we just needed to have a sub team dedicated to the ground systems because if you don't have the testing equipment right, you just can't do a test, right? And so it's a new team, and we're very excited for it. They're doing a really cool work in developing the trailer that you saw that Titan was mounted to, and hopefully one day they'll integrate it with the launch rail so we can have a mobile launch platform, which I think would be really cool. But time will tell.
Go on the offense.
We don't build missiles.
We don't go on the offense.
We don't.
As far as the feds know, we don't build missiles.
We don't build missiles, but then again, we haven't found a way to build a business model for the club yet, so who knows?
We will.
That's you don't get to know anymore until you're in the club. Then you get the
all right. Rest of propulsion.
We don't have any non-disclosure agreements for you guys to sign tonight, so if you want more, come on down to the meeting.
Oh my god.
Freaking Austin is keeping us honest down here.
All right. Okay, so running through all the prop teams. All right, so see you, Nancy. So running through the prop teams, we have Luna, which handles all the testing that needs to happen and all the things that need to happen for Luna to get tested successfully. We have Titan, the Titan sub-team, who does a similar function, but they also have a really pronounced design bend to them this year. I forgot to mention, Luna does a lot of data analysis with the regression of the fuel grains.
Yeah, that was our new project.
And if you have any questions, talk to Nick about it because he is the Luna lead. And then we have Nozzle, which is what I used to do. They design and build all of our rocket nozzles. And then from there, we have ground systems, which I mentioned. And finally, last but not least,
we also have fluid flow.
Oh, yes,
we also have
fluid flow. Good, thank you for testing me. We have fluid flow. They design our injector plates and they help work with our flowing systems. And now, yes, and now,
we have chemical. Best sub-team, in my totally objective opinion. Our two big projects are the fuel grains for both Luna and Titan, and igniters, which ignite both engines, which we're working to be able to completely produce by ourselves. We used to get them from an adult mentor, and we're working on optimizing our fuel grains and making them a little more efficient, more powerful, without going over the imposed limits on impulse and size.
Freaking Uncle Sam, man. God damn it.
I hate laws, right?
For avionics, I did forget one sub-team. Sorry, certificates. Technically, certificates falls under aerodynamics, but usually it's like, although it's under aerodynamics, usually like prop and avionics people also like heavily participate in that program.
Okay, cool. Yeah, so for avionics, there are 3 sub-teams. We have avionics testing, which is kind of the group that you'll have working with all of the rocket testing, so the ones that ignite the rocket and then get back data from our sensors we put on the rocket for our test. Then we have avionics flight instruments teams. They're the ones who work with our rocket in kind of like a ground station, enabling communication between the rocket when it's in flight and ground, so us. And then we have the avionics R&D team, which just work on research and development for like any new projects we want to do. I think we kind of had like a subset of it last year, even before the official R&D, or so last year R&D was working on like our flight systems stuff, but now that we have that kind of established, it's working on, I think, newer projects such as making sure our antenna can handle the range between our rocket and us. So yeah.
Yeah.
All right.
So much more every team does, but just a little summary. I think we have one more like conceptual question, and then we can start doing some of the more specific sort of technical stuff. Should be fun. Is what are some other aerospace clubs at Rice, and do we do any collaboration with them?
Yeah, so SEDS, for example, so I see some people in the chat mentioned it. So there is another like the other significant, it's called SED Rice, so it's the Students for the Exploration and Development of Space. It's an acronym there. That is a national organization. It might even be international now. It has chapters at a bunch of different universities across the country, and there is a chapter at Rice. So we're like a very, very focused, like we do rockets. Like that's our technical focus of the team, but SEDS is a little bit more general, just kind of doing like general like promotion of space. And they do things like they host conferences. Every year at Rice, they host something called the Owls in Space Symposium, where they bring speakers and companies from different, across the aerospace industry, and panels and things like that. The administrator of NASA actually came to one 2 years ago, which is really cool. The administrator of NASA, fun fact, is a Rice alum, and guess what? He's a Loveteer as well. So not only have we infected Rice Eclipse, we've infected the leadership of NASA. But anyway, I digress. So SEDS is a very big team. They also, beyond more like general air, like space outreach stuff, they do have a technical project, which is called OwlSat. So they're building a CubeSat to launch into space, which is really, really cool. So if you're interested in like,
all right,
just to be a site engineer, for example, like that's a very awesome team at Rice that you should definitely look into. But that being said, also like we have a lot of people on Eclipse who have, like, even though we build rockets, like we've sent people to do space stuff that are not just rockets. Like people on Eclipse have gone to build satellites. So what you like for sure. Those are really the only 2 big ones. There's also an AIAA chapter at Rice, which is American Institute of Aerospace and Astronautics, maybe.
Let's go with that. Let's just roll with that.
Something like that. They're not they are like kind of active at Rice. It's not a super big organization, but they do some lectures during the year that are kind of aerospace related and stuff like that. So we don't really do any direct collaboration with them, but we're sort of trying to get more involved with them just because it just kind of is helpful to us to be aware of what they're doing. But like, yeah, we're going to try and do some like joint social events next year with SEDS, for example, and help them out with their symposium. definitely check out those teams as well. And also, like, I saw those
Jeff, you're freezing up.
electric vehicles, other design teams. Oh, sorry.
You're good now. Oh, never mind.
Okay.
Make it.
Yeah, so like Hyperloop and electric vehicles are also like design teams at Rice. So there's a Rice Hyperloop team. They design I think it's called a pod for the Hyperloop competition every year, which is Elon Musk's like super high speed like transportation concept. So there's a team at Rice that does that, which is really cool. There's also Rice Electric Vehicle, or REV, which they do electric vehicle design. Also a very cool team. And if you know you're interested in like electric vehicles, for example, that's a really cool team to get involved in. I think it's less like racing and more of like kind of endurance vehicles is like the competition that they do. They're also a smaller team compared to Eclipse, but they are like, if you're interested in that kind of thing as well, like definitely check them out too. We're not trying to like limit your options on like exploring design teams at Rice. Like please join what you guys want to and what you're most interested in. Like we all love Eclipse, but if you find you like electric vehicles more, then please join Rev and you'll have a great time. But just know if you want to come back to Eclipse, we'll be happy to have you.
Yeah, and you know we joke a lot with the different clubs. Like we have a good banter, but at the end of the day, we're all trying to just have some fun engineering stuff. And so however you want to do that is great. If you want to do Eclipse, wonderful. If you want to go work on electric vehicles, more power to you. Get more power from the sun. Yeah, it's whatever you want to do, and we really love working on Eclipse, and we love being able to, you know, go to school with some really powerful, pretty dedicated people who are passionate about, you know, engineering in general. So yeah, don't feel like you're just like, oh, I went to an Eclipse meeting before freshman year, so I'm just stuck in Eclipse now, I guess. Like branch out and go explore, because we're not trying to limit you guys in any way.
All right, so it's that time of the year, or it's that time of the night. It is 9:30, so we are well past our schedule to end, so by no means do you have to stay. But there are a few more technical questions that we're going to get through. So if you're waiting for your thing to be answered, stick around, or if you want to hear more technical stuff, come hang. One of the questions I do want to do, though, is that if there's any... Okay.
Yes,
all right.
I guess before, I just wanted to say, sorry. Before everyone goes, also, I'll do this at the end too, but if you're interested in like getting connected with Eclipse, once you start at Rice, we hold like new members info sessions like this basically, but like at Rice at the beginning of the semester. So if you want, like in terms of like what to do like going forward, like thanks for coming out, but like once you start the semester, like keep it on all appropriate channels so you're aware when they'll happen. But that's sort of the next step for you guys if you're interested in Eclipse. But anyway, that's all I had to say. So anyone who's leaving, thanks for stopping by, and we can now get into the technical stuff.
All right, before you do Aerospikes, there's a question I do want to just make sure it's been asked is, are there any recommended reading or things to learn to prep a little?
We do not require any amount of summer work. You guys do not have to worry about that whatsoever. We will teach you guys everything you need to know because we are very, very, very dedicated to the idea that you do not need any prior experience to join Eclipse.
Enjoy your summers.
Enjoy your summers.
Do whatever you want.
Do whatever you want.
If you want to read rocket stuff, do it.
If you want to read rocket stuff, we can make some suggestions. So I think a great place to start, if this is not required, this is not something that you need to do, but if you just like rockets and you want to learn more, there is a book called Ignition by John D. Clark. I'll write that in the chat. It is an incredibly fun book about rockets, and it gives you a great rundown of the history of rocketry. And I had a lot of fun reading it. So if you want to learn more about rockets, that's a great place to start.
But also, you do not need to do this.
You do not need to. You do not need to. You do not need to.
I'll also put it out there again as something you don't need to do. Bless you. But it's just like it's a thing that we look at Eclipse a lot. It's called Rocket Propulsion Elements by, I think it's Robert Sutton.
Yeah.
I'll put this in the chat too. It is a textbook about rocket propulsion, which is it's a hefty book. And it's like, don't like try and sit down and read that thing cover to cover. Like, it's like, that's terrifying. Even like for me as a senior, it's like, don't do that, please. Like, it's a very helpful, that's some of the more like really in-depth stuff about propulsion, and you just have some free time and it's like you're bored and you want to look at that. Like, that's another thing that you can look at. Like, again, no requirement at all. Like, just if you're interested in like looking a little bit at propulsion stuff. And also that book kind of goes deep dive into a lot of things. Like, at least as a student, like as an Eclipse member, I found it was easier to learn from the leads and sort of boil it down into what I actually need to know versus like a textbook. But if you really want like some deep dive into propulsion stuff, that's another good one. So I'll put that in the chat.
All right. So there's only a few y'all left. So if you want, you can unmute your mics and turn on your videos if you feel like it. There's few enough people that it's not going to be that chaotic. But I hear that you're interested in talking about aerospikes, Mike.
Okay, this is the moment I've been waiting for. I'm so excited. Okay, so aerospikes. So the normal way that a rocket engine works is that you funnel the gas through a bell nozzle, right? That's how it kind of works. And so what happens is that the pressure difference between the exhaust gas and the atmosphere is going to change. And that can mean that you have a horizontal component to your thrust, which is wasting energy and not being productive, right? So what an aerospike does is instead of like fighting the atmosphere, you're going to use the atmosphere as your engine nozzle. And so you have a cone that you inject propellant gas around.
Sort of looking for a physical example.
Sort of like this cup that I have now poured everything out of, but you would inject gas along the side of it. This would be a truncated cone, a truncated aerospike. The normal one would go all the way down to a point. And so you inject gas off the side, and that would help you be more efficient at much different altitudes, like ground level all the way up to a vacuum.
But Mike, why aren't they used everywhere?
So here's the thing about an aerospike. Yes, it is more efficient, and yes, it does save mass. But here's the thing. You're shooting something with stuff that is much, much hotter than lava. It can like the exhaust gas in the space shuttle, for example, can vaporize steel. Just like, bam, it's a gas now, right? And so the heating of the aerospike is insane. And so you have to find a way to cool it down. And you can't just use a radiator like in a car. That's not going to work. You got to find a way to use pumps to force coolant through your aerospike. And so now all of a sudden we're talking about cutting holes, weird geometric holes into material and then pumping liquid through it, which was really hard. It was very, very difficult for a long time, and people never thought it was going to happen, but was. We now know how to do it. 3D printing. You can use a 3D printer to print like cooling ducts into it, which is why the nozzle team is now doing research on 3D printing, so that way they can see if we can integrate a 3D printed nozzle into our engine. And then
not an aerospike, but
if that goes well, someday, maybe, if I have my way, we can have an aerospike.
Speaking as a former nozzle lead as well, it has been a pipe dream of the nozzle. I shouldn't say pipe dream, but it's sort of a pipe dream of the nozzle team on Eclipse for its entire existence to build an aerospike. But for now, still hasn't happened. They're really cool, but we want to get our first hybrid engine off the ground before we start going into that.
Yeah, nozzle team just always has a bunch of dreamers.
It's so
beautiful
fun.
In a way, but also tragic.
The new nozzle lead is pitching active cooling.
I'm so excited for it. I'm really.
Yeah. So, another question, which is kind of a cool thing, is can you talk more about the Titan II engine and when it is set to be completed?
So, funny thing about Jeff is that in addition to being the president, he's the former Titan lead. So, Jeff, do you want to take it away?
I am, yeah. So the Titan II engine is, it's the flight optimized version of that Titan engine that I showed you in the video during the presentation. So, like, it's like the same scale of engine. So it's 800 pounds of thrust is what it produces, and it burns for 11.5 seconds or so. So it burns a little bit longer than Titan 1. But basically, we took that original Titan design and trimmed it down and cut mass wherever we could and made the thing fit together better just so that we could actually fly this thing in a rocket someday. Or not someday, I should say. We are planning to fly this thing in the 2022 Spaceport America Cup rocket. So that's not this coming year, but the year after. So your guys' sophomore year, for all of the new or the prospective members on the call, that's when the engine, technically Titan wasn't the most powerful engine we can build. Titan 2 is actually the most powerful rocket engine that we're legally allowed to build before we get into FAA stuff. So that thing it's like, I think it's around 10 feet long, just the engine itself right now. And again, it's a pretty significant, pretty big engine, pretty big project for us. We're going to actually manufacture and put the engine together over the course of next year. And we hope to do at least one hot fire test at the end of next year, academic year, potentially. The manufacturing and buildup of the engine goes, but this engine will be fired either at the end of this coming academic year or the year after at the beginning. And it's going to actually be built over the course of the next year. So that's sort of the sense of the timeline in the start of 2022 at the Spaceport America Cup.
Yeah, and in addition to being 10 feet tall, the rocket it's going to go into to fly is going to be close to 20 feet tall, which is just really exciting.
It's a big boy.
And we just had an internal design review, like the second one, to finish up like the design stuff. We have not started making it, which means that you guys will be helping build it from the ground up from day one.
And it also means that just because things are like it's on paper and not manufactured yet, we still have flexibility in what the final design is. So just because we have an idea now of what we want it to look like does not mean that it's set in stone. And so you guys can have a chance to be directly involved in like finalizing and manufacturing Titan 2, which the idea of Titan 2 was kind of the founding dream of Eclipse, was to build a hybrid rocket and fly it. And, you know, there were a number of reasons why it's hard to bootstrap a rocket program. And so it's taken us a little bit to get there. But we've hit our stride and we're well on our way to making it happen. So we're very, very excited for the Titan 2 project.
Yeah, and the aerodynamics team is actually going to start putting together the airframe or designing the airframe of that rocket this year, as a matter of fact. They like, if you want to actually start like getting in on the design of the rocket that will be powered by this engine, that's also starting up this coming year.
It's going to be an amazing experience because it's going to be an integrated, like, organization-wide project between different teams and departments, and it's going to be crazy.
Yeah, it's always been the idea that like one day we'd work together to make this project happen, but one day is now tomorrow.
Yeah,
to see it happen.
Like there's well over 50 active people at any given time over all these sub teams, and soon we're all going to be doing one project. It's going to be amazing. When you're designing a rocket or a system, how long does it usually take, and what are the cycles like? Hello.
I'll like speak first with the rocket.
Sure.
I'm going to repeat the question. We had a new friend just join us.
We're still connecting the audio though.
Yeah. I'm going to wait till he finishes. Oh.
That's an awesome logo, by the way. That's
all right. Hello. All right. So I'm going to repeat the question. So when you're designing a rocket or a system, how long does it usually take? What are the design cycles like?
So usually during the first month or two of the school year, the airframe sub-team of Aero, so I don't know how much I should go back, but basically they'll start designing that year's Spaceport America Cup rocket. So like I mentioned earlier, they're the ones who like dictate what the fin shape is going to look like the body tube lengths, like the nose cone we're going to use that year, etc. So they'll be like designing it, and during that time the other Aero sub teams will be doing their new member projects, so like getting their members used to certain software we use, or like certain projects that we still need to get done that will help our later like design or building of like other subsystems of the rocket. So that's basically the first month or two. After that, that's when the sub teams really start working on designing. From there, like usually we try to be done like building the rocket by December, That way we can start testing, like having many tests done, like test launches during the spring semester, and then make changes if we need to. But in recent years, we've dramatically increased the size of our rocket. So usually we go to like January or February, finishing up building our rockets. But we do try to finish it as early as possible so we can get as many test launches as we can.
Yeah, so we put out a new rocket every year. Like it's sort of like every year is a new rocket for that cycle.
And what's going to be unique though is that this year.
Did I freeze?
Yeah, but we still heard you.
Okay.
But yeah, what's going to be unique is that this year aerodynamics isn't going to be working on one rocket. Instead, we'll be working on 2 rockets. So we'll be doing our normal Spaceport America rocket. So like the design and build schedule I just outlined. We'll be doing that for next year's Spaceport America Cup. But in addition, we'll also be starting the design for the Titan airframe, which is going to be our rocket for 2 years into the future, like not the next one, but the one after next, like that competition.
And so, like we said, this is a project that happens every year. And so every year new members have a huge contribution to our rockets. And so don't feel like you need to have experience. We have a lot of practice doing this. And every year new members make a huge contribution to it. So don't feel like you need to have any sort of prior experience, because we keep saying it and again and again and again, because we really mean it. You guys do not need to have any experience on day one to start making meaningful contributions.
I knew absolutely nothing, like nothing about space or space history. And then
here we are.
Sure, and you learn a lot. I mean, regardless of what your degree is, like for me, I'm a mechie major. I'm learning stuff that I won't get to in my degree plan for another year and a half.
It's not just technical information, like you learn how to troubleshoot and solve problems. Like we had an issue with contamination last year, and I learned more from dealing with that and working out how to like test for that kind of contamination in the future than I did from my Orgo lab that semester. So that was a great experience.
Yeah, there's all sorts of like soft engineering skills that like the curriculum and all the degrees focuses much more on like the hard skills, like formulas and cycle like stress lives and fatigue and all that kind of stuff, and that's important. But there's a lot of soft skills that go into like, okay, but like how do I actually like run a project, and like what happens, and like how do I actually like go from, hey, I have this awesome piece of paper that has all my drawings, all my calculations, and I know that it's going to work, but how do I actually get that piece of paper and turn it into a rocket or a system that can actually fly? And that's really what Eclipse focuses on.
Yeah, and I know for avionics, Rice's electrical engineering program focuses a lot on digital signal processing, but there's a lot of like analog skills that are important in industry, and then Eclipse is where you is like one of the places you can practice them at Rice. And along with like working with industry software.
And one of the great things is in real life, not everything is a team effort, literally everything. And Eclipse is a great experience where you really just can't do the stuff we're doing on your own. You just can't. And so you get an amazing experience working on teams with almost everything. The next, last question I have is, do other schools at the Spaceport America Cup have those licenses to build rockets with more power than Titan II, or have we hit the ceiling?
So for the Spaceport America Cup, there are rules for how big you can make your engine. And so if you're flying at that competition, which is like, again, like the biggest in like the world at this point, like that is the engine that we're building is the most powerful engine that you are allowed to build. And the reason for that is because it is the most powerful engine that you can build before hitting like FAA regulations. So like there are rocket teams around the country that have like built rockets to try and like break the von Karman line, which is like the 62 miles in the sky, which is like the sort of unofficial like space boundary, I guess. And like those teams, like they're not launching that rocket as part of the competition. They have to get like a lot of special clearance. Usually they work through their university to do that, to like go to space basically. So like that's really cool. And like that does exist in some universities. Like someday Eclipse will probably be at that point, but at the moment, like we're so like at least at Spaceport America Cup, like to answer your question like directly, no, like there's no one with those licenses just because like it's you would break the rules of the competition. But like there are student teams out there that have built more powerful rockets, but you just have to like go through a lot of like work in order to like to get the even just like on the legal side in order to be able to do that. So it's cool, and like we'll get there some way at some point, but we're not there yet.
And this engine, as it is, already stretches the limits of what we're capable of manufacturing. So like we're a really young club, but we're growing more and more. So a college like USC, that Austin said, they had their own warehouse, like all these machines, and and they did make it to space. But if you ask me, they used a solid motor, so
And I mean, I don't want to talk too much shit about our peer institutions.
That's the best way to start it. Sounds like an essay meeting.
But at some places that I will remain unnamed, the student-run rocketry teams are really run by faculty, and so like technically students are involved, but the faculty are like doing all the heavy lifting and like doing all the work and just kind of like keeping students attached to it for some reason. So the thing about Eclipse is that we are the ones doing the work. Like we work closely with our faculty, but they are not doing our engineering for us. We are doing it ourselves. And so USC is wonderful. It's great. They do great work. But the amount of actual students like actually doing all the engineering is different than what we do.
Yeah, and like USC, for example, like they built like a solid rocket motor to go to space, like Mike said. And like at Eclipse, like the engines that we build hybrid rocket engines, which are basically they have a solid fuel and then a liquid oxidizer. So like in order to have any sort of combustion, you need like a fuel, like wood, and you need some kind of an oxidizer, which for like a fireplace is just like the oxygen in the room around you. So with rocket engines, because in space there's no air, you need to bring your oxidizer with you.
Or bring your air with you.
Pretty much, bring your air with you. So we do hybrid engines on Eclipse, which is there's a solid fuel and a liquid oxidizer, which beyond being safer and a little bit simpler, which makes it easier for a student team to work with, you will learn the fundamentals of propulsion for both solid rocket motors with like the regression of the solid fuel grain, as well as liquid rocket engines with the propellant feed system for the oxidizer and the injector plate that Mike mentioned when we went over the propulsion teams. So like when you work on Eclipse engines, you'll learn like the systems and fundamentals of like both solid propellants and liquid engines. So like because of that, they're a very good learning tool for any student who wants to learn more about like propulsion. So that's another main reason why we do those engines specifically, just because like, again, we want to win and we want to do cool stuff. We want to win Spaceport America Cup and do like crazy things as a team, but we also want to teach you guys. That's sort of the most important thing. And those hybrid engines are the best learning tool for that.
Also, I would like to add that the point of the Spaceport America Cup isn't to go as high as you can go. Like there are two categories, or like two height categories, a 10,000 foot and a 30,000 foot. Like if you go to like, let's say 100,000 feet, like you're going to lose the competition because they score you on how close you can get to that like height. And like how, like, so apart from trying to get as close to that 30,000 or 10,000 foot mark, it's also what do your simulations show and how accurate were your simulations. Like it's more about precision than just let's see how high we can go.
Yeah, and recovery. Yeah.
Yeah, and recovery. Let's not break the rocket once it lands.
Yeah, and in real world space flight and real world aerospace, it's that precision and recovery that counts. like when you're flying someone to low Earth orbit or to the moon, like the most powerful thing in the world doesn't matter. It's can you actually get there and safely bring them back. So that's the most important thing.
All right, so if anyone has any other questions, you can just unmute your mic and ask it. Well, I'm going to ask my own question. What is the, I actually forgot, let me pull it up. That's why you write this down. What is your fondest memory of Rice Eclipse?
All right, who wants to go first? I can go first if you guys want. Okay, I'll go first.
Go first, sure.
I love the sound of my own voice, so I'll just keep talking. I think my fondest memory is when I went to my first engine test. And you know, you spend so much time like working on these things and you know, getting all the prep work and everything done, and you know, looking at you know all the numbers and running the math and everything, and then actually like putting it together and going to the test site and you know, drilling into concrete so you can mount the test stand, and then actually hearing it fire is just such an incredible experience. It was so much fun, and it's really remarkable, and I had so much fun doing it.
I don't think I could pin it down to one, but like one of my favorite things from Eclipse is that avionics usually does avionics social nights before a test. So we'll all get together like the night before a test in the ODEC, and we'll kind of be like half working on things, half like maybe playing some games or watching like some movies or TV. And then we sleep in the ODEC, so we don't have to, so it's like reliable that we wake up and go to a test.
Mine would be the Titan test, which because it took pretty much the whole day, and it was just a really great experience because we had to go to a farther test site for that engine, and it was just sort of, we did it at the end of the year, and it really felt like just the culmination of that project and everything that we'd been working on, and to have it be successful and such a fun experience to be sort of traveling with people, and we had to do a little troubleshooting at a site, and it was just like just great all around.
For me, like I also can't pin it down. Like there are so many great things that I love about like the club. Like so I was the structures lead last year, and like one of the things we do is like we go to this taco place in Houston, and like we like go watch a movie and then just like eat there and just like hang out as like friends. And like I love that, but I also just like going to launches, like actually being able to see like something you made, whether it's like the actual competition rocket or just like the certificates rocket, and just like being able to like see that go, like that is such like an amazing sight to see. But sorry, I'll go. But also like from a lead's perspective, what I personally also really like is like seeing how much like my sub team members grow. Like you have like a group of students who at the beginning like know nothing about machining or like designing or whatever you do. Like maybe there's a couple who know what they're doing, but like for the most part they don't. And then like a few weeks after, like middle of the semester, by the end of the semester, you just like see them grow so much and like see them surpass you in some things, and it's like so amazing.
Yeah, for me too, it's kind of impossible to pin it down to one thing. Like one of my favorite memories of Eclipse is back when I was a freshman. I remember I had gone to, it was called a cold flow test of the Titan engine, like another iteration of it back then. So a cold flow test is like, they basically do everything with the engine except light it on fire. Like you fill it with oxidizer, you set it all up, you get it all ready to go, but you just don't actually like hit the ignition button. And I would, during that time, and it was super duper seeing how this whole big engine like got put together. And then like after the test, the design lead at the time, his name is Andrew Gatherer, he's now at Stanford. He just kind of like pulled me aside and said like, hey, like you are the only freshman out there. Like we really, really appreciated you being out there, and like you really, really helped that day. And like we just wanted to thank you for that. And like that was like the moment that sort of hooked me onto Eclipse, where like like I could tell that like the upperclassmen on the team were very, very motivated to like bring the new members into the fold and really, really help them learn. And like that sort of is what started me in many ways on Eclipse. And now sort of here I am like 4 years later with a NASA internship and president of the team. And like that kind of is like just sort of seeing that arc all the way like back to like an upperclassman reaching out and saying like, hey, like you did a really good job. Like, thanks for being here. Like that's just sort of sums up like the mentorship culture of Eclipse to me, like in a single thing. Like it's just kind of proof how valuable that is. So I just wanted to emphasize that again as something that's very important to everything that we do.
And he got you. He roped you in.
He got me right in the heart, right in the feels, Jeff. Oh man.
No. Well, I have a completely different fondest memory. In almost everyone's fondest memory that they've said has had to do with like a great success of the club. Mine was actually our most recent failure, where we had a critical anomaly on an engine test and no one knew what happened. And we had this all hands meeting in a big room where we had the videos of the anomaly. And that's all I'm going to say for now, the anomaly. It was spectacular. And all like the data the avionics people recorded, the graphs and, you know, just a bunch of charts. And everyone was just spitballing theories as to what could have gone wrong and drawing stuff on the whiteboard. One of the other officers came in with a PowerPoint presentation loaded, you know, and then just shot off all his bullets, and then when none of it stuck. So everyone just started guessing about what happened, and we ended up constructing a timeline. It was just this nuts 2-hour meeting that I'll never forget.
Yeah, in terms of projects, like my fondest memory has definitely been like going through the Titan II design, like which basically was a redesign of the engine from scratch. Like we literally got to go through and like design a whole new rocket engine. Like that's something that like everyone on that team on Eclipse can say that they've done it right. Like I built a rocket engine, which is like so cool. So like it's amazing.
Yeah, it really is a special club, and I might be a little biased, but I love everybody that's on the team. It's so nice to get to know you guys and get to work with everyone here. So I really I'm really looking forward to. I don't know what you guys will decide to do, but hopefully you guys will come on out to at least a couple of meetings and, you know, become part of the team. I'm really looking forward to having you guys on it.
Really. Well, I think that's all we have for now. Thank you to the few trippers who've stuck it out.
Yeah, thanks for sticking around. And like I told everyone before, like if you're interested in getting involved, just keep an eye out for those new member interest meetings at the very beginning of the fall semester. Like we'll advertise those on like college Facebooks and through O-Week advisors and the ODEC and just other channels like that. But that's kind of like sort of, it's like this, but like a little bit more structured, where we sort of go through what the team is going to be doing for next year just so you know what's going on. But definitely keep an eye out for those. And if you have any other questions, I guess like you guys all, he can like sort of flip things onto us if you have any specific